My pleasure now is to introduce Dr. David Thornburg, who absolutely is one of my heroes in this business and one of the first people that I looked up to when I started working for NSBA a lot of years ago. David has been at the forefront of education technology for 4 decades, and his recent work involves the transformation of learning spaces to support interdisciplinary project-based learning. David?
Thank you so much. Wow. Well, the title of this talk, Learning on the Holodeck, has a subtitle, and the subtitle is Theaters Without Audiences. And as we go through this presentation, I hope that the concept of theaters without audiences will make some sense to you. But I'm going to start with our Wayback Machine set a long time in the past to point out what I think is a huge problem in education. And the problem is that for too many children, school sucks. But it isn't because today's kids are digital natives or, and we're digital immigrants or any of these other things. It has always sucked. So here's a painting that was done in the mid-1300s, and I want to draw particular attention to this classroom in Bologna, Italy, because when you look closely, you'll see one of the students is sound asleep. So we know that the spray and pray model of education, the full frontal teaching model, doesn't work if that's the dominant paradigm, if that's the only way people learn. And yet, what have we done throughout the hundreds and hundreds of years since? We have codified that into a standard model. Now, it's not the only way that classrooms can be set up, but it's a dominant way that they're set up. And some time ago, there was a book written about student learning and the proper environment for students by Harold Rugg and Ann Shoemaker. And in this book, Harold said something really interesting. He said, desks in rows, a characteristic setting for the traditional education and typical of its spirit too. Desks in rows to prison unwilling and recalcitrant youth while education laid its heavy yoke upon them. Children required to sit still, freedom of movement denied them. Repressed and quiet, they were crowded into huge classes where personal identities were thwarted, if not entirely submerged. This was written and published in 1928. This is not a new idea. And yet, we take a look at the modern tools of today, like Second Life. Most of you in this room, raise your hands if you're familiar with Second Life. The way you move in Second Life is you teleport from one place to the next. You don't walk, you don't take a bus, you teleport. It's a future world. You can make anything happen. So I went to Second Life and I did a random search on classrooms, and what did I find? A classroom in Second Life looks like a regular classroom. What are they thinking? You can have anything, and we replicate a model that we know hasn't worked since 1350. So that raised the question, is there another way? And when we talk about the things that were just presented so eloquently, for those kids who are really self-directed, who want to go and pursue knowledge on their own and take control over their projects, yes, there are ways to do it, and there are some people doing a brilliant job at it. For example, Walt Disney. You go to Epcot and you go into a project like Mission Space, and you are completely immersed in a 3D environment where you're learning how to navigate a spacecraft to another planet and land it, if you're lucky, successfully without crashing. The problem with this is that this learning environment only holds 4 people at a time, and the mission is fixed. But it's an interesting idea. Google raised the bar a little bit at the TED conference this year with something called Liquid Galaxy. Liquid Galaxy is like an elevator with glass windows, except the windows are display screens. And when you're inside Liquid Galaxy, using Google Earth, you now are flying above the Earth, and you could go any place you want, including undersea now, and navigating around this entire planet. Problem with Liquid Galaxy is it only holds 8 people. So if we want to really create an interesting technology-based learning environment for schools, it's got to hold at least 30 people. And so we did research on that, and the one that came to mind that worked really well is fictional. It's the holodeck that first showed up in Star Trek Next Generation about 25 years ago. And the holodeck is an empty room that can become anything under the control of computers. It could become a pirate ship. It could become a Victorian drawing room. It can become anything else. It could become a spaceship within a spaceship, if that's what you want to do. And we realize that today, with modern technologies, we could build kind of a holodeck, accepting that it wasn't going to be completely empty. It was mostly an empty room, but it could become anything that we wanted. And so we started a project called the Educational Holodeck. And the Educational Holodeck, the first thing we had to do was figure out how to really cover an entire wall with images. So our holodeck model uses a front viewport, and we've modeled this just using desktop screens. But when we have it on the wall, it's actually a screen 6 meters across, 1 meter high, which is pretty impressive if you're inside that room, because you feel like you're completely surrounded with images. And this is a schematic. This isn't exactly what our first room looks like, but it does show the front wall with these large displays, and then other projectors in the room on the other walls, so that when you're in this environment, you truly feel that you're immersed in a completely different type of learning space. And the Educational Holodeck has got 3 characteristics to it. The first is the physical environment. That's actually the easiest part of the whole thing. The second is the missions themselves, because the missions are interdisciplinary. We don't just talk about math by itself or science by itself. It's all interdisciplinary work. And that is reflective of real life. We don't divide real life into these nice little segments. They're interdisciplinary. The third part, absolutely essential, is staff development. For over 20 years now, I've been saying that if we go into schools with a lot of technology and we don't provide appropriate staff development, the only thing that changes is the school's electric bill. And so this is especially true when we start doing edge-pushing types of technology driven by inquiry and project-based learning. So on that, in that regard, the holodeck has 5 attributes. It's immersive, it's interactive, it's interdisciplinary, it's innovative in the sense that it supports student creativity and creative problem solving, and it's interesting to them. And if it misses any one of these, it's a failure. And it's an interesting idea to take this and map this against things that happen in ordinary classrooms when seen through the eyes of the students themselves. Very few students that I've encountered would list these 5 eyes as a description of what's going on in their history classrooms. Not that some wouldn't, but many would not list this. And when you have all 5 of these, you have a word that was used in the previous talk that I really like, engagement. And engagement is essential to learning. So with that in mind, let's take a look at a real project and some of the things that we're doing. As part of World Space Week this year, we did a project. This is a UN project with countries all over the world taking part. There were 5 entries from Brazil, only one of which was in a school, and it was our project. It was called Mission to Mars, The Search for Life, and it was a middle school project that we did, and it was the test run, the test flight, if you will, of the holodeck. We weren't quite finished, but we got things to the point where we could actually work with kids in it so that we could learn from it. And the way that this mission started out is with a driving question. And the driving question is, how could you tell if something is or was alive? I think middle school students ought to be able to answer questions like that. And so we thought that would be an interesting driving question to use on this mission to Mars. So we started out with a briefing. And the briefing was just based on history. And there was a little video that they watched. And in that video, they learned about Percival Lowell, who in Flagstaff, Arizona in 1895 spent a lot of time studying the surface of Mars with the telescope there, and he thought he saw canals on Mars. It was an optical illusion, and from these canals he concluded that Mars at one time had intelligent life. He was wrong about that. He was wrong about the canals, but that was the nature of the optics that he was using at the time. So there was this myth that there was life on Mars going back a long, long time. More recently, the students learned from this video about the Allen Hills meteorite found in Antarctica, which when examined under a scanning electron microscope shows what appears to be fossilized bacteria. And so they're just given this information. Then the Phoenix probe, the Phoenix lander, which found ice on Mars and also found salt, which, as you know, when you put those together, means that we're very close to discovering that Mars at one time had margaritas. And so the combination of these things leads to the suggestion that maybe there is or was life on Mars. Then, every spring on Mars, there is a release of methane gas. This year, 19,000 metric tons of methane gas released into the environment of Mars. Where's that coming from? All the non-biological reasons don't meet the criteria of Mars. The only option left, in most people's thinking, is biology. We don't draw conclusions for the students. We just provide the data and then let them loose to form teams to take a spaceship. This is the picture of the Beagle, our spaceship, from the Earth to Mars, and to examine it themselves. Now, they have a complete instruction manual on the spacecraft. This is a snapshot of the first HyperStudio, if some of you are familiar with HyperStudio application, running on an iPad. It's a research project right now from HyperStudio, and it's an interesting project because it was a hard time getting this thing working. We're not quite there yet, but we're awfully close. But just some really fun stuff, and having these in the hands of kids, this type of tool, I think, is potentially very, very valuable, very important for them. And what's amazing when the kids go on the mission is how engaged they are. The child who's standing in this picture is a real problem in traditional classrooms, but in this room, he was a leader, he was doing tremendous research, he was making great progress, he was having a fantastic time. The kid that he's standing over actually wants to go to Mars now, and he realized that he's going to be old enough he wants to have the requisite skills to be able to be an astronaut someday, largely because of his experience on this prototype mission that we did, which is fun. This is kind of a general snapshot of the room. You can see that 6-meter screen up in the front, pretty impressive size, and then an interactive board on the side where students can interact with everything. That's the mission control panel, so they make choices there, and we use Celestia as the software for the Mars trip, and we've got it set up now so that as you do things on this board, the front screens change to be reflective of what the students are asking this to do. We do no direct teaching, and the reason is because every person in that room is an actor in a play. There's no audience. It's a theater without audiences. So you can't give a lecture because there's no one to whom to lecture. Everybody's an actor. And that means that the teacher has a role. In this particular case, the teacher is the mission commander. So with that in mind, we go ahead and get the project going. We have the students going through, and as they go through this project, we measure what it is they thought about Mars before they get started and what it is they know about Mars after the mission's completed. So after we get back to Earth, we do the final wrap-up, and the final wrap-up looks like this. Before, the students, and this was just asking them questions, thought that Mars was hot, didn't have any water, it's red, it's a solid planet close to the asteroid belt, you could see it with your eyes, it doesn't have life. These are just, some of these things are true, some of them not true. After the mission, they had a lot more information. It might have life in the interior, it has ice, it's cold, humans never went there before, has 2 moons, etc. They learned all of this with no teaching. They learned it through their own discovery, through their own projects. And I think that that is really the key point here. You create the kind of learning environment that supports this, you're going to have transformative experiences for students. So we're breaking the model of traditional spray and pray education, moving towards inquiry, project-based learning by something as simple as changing the furniture and changing the room. Thank you very much.